Hi all. In this video, we'll check what are the different types of wind turbines, on what basis they are classified. It is actually classified on various criteria like based on the position, on how it rotates or the rotational axis, or it's just based on the size of the wind turbine. So it's like based on the power capacity, we call it as small, medium, and large, based on the axis position or the rotational position, axis position, horizontal or vertical, HAWT or VAWT. So you know, horizontal axis wind turbines are more common than the vertical wind axis turbines. We would have even seen more of this horizontal axis turbines. Um, you know, it has in this type of HAWT type methodology or the method or the type or the classification, the shaft are positioned horizontally, which helps helps in ease of conversion of the wind energy, linear energy, into rotational one. Whereas in case of VAWT, which is nothing but vertical axis wind turbine, it has few advantages compared to the horizontal axis type. They are like the electrical machine or the actuator and the gearbox can be installed at the bottom of the tower, unlike in case of this horizontal, where we have the in the we have seen in the previous video the nacelle and the tower and all those pitch and control and all gearbox mechanisms, everything we have described or discussed. So that is one of the advantage. And these components have to be another advantage, or you can say that the vertical axis wind turbine has this. They do not need the yaw mechanism, since the generator does not depend on the wind direction at all. So the most famous design is of the VAWT is the Darius type of turbine. There are few disadvantages in irrespective of this disadvantages. That disadvantages are nothing but that it limits the utilization of this vertical is the due to the design of blades. The sweep area in this type of turbines is much smaller, and so the wind speed is slow near the surface and usually turbulent. Hence these type of wind turbines harvest less energy compared to the horizontal axis type. And additionally, vertical axis wind turbines are not self-starting machines and must be started in a motoring mode and then switch to generating mode. So that is another drawback or disadvantage of VAWT. Moving on to this power capacity, the size, as I mentioned, small, medium, and large. It's based on what is the requirement, or say for an example, the output power rating of an example or a scenario of small wind turbines is less than 20 kilowatts, and this type of turbines are used for residential applications, supplying households with electricity for local small circle or a residential part. And they are designed for low cut-in wind speeds, generally 3 to 4 milliseconds. And they are also suitable for meter per second, sorry. They are also suitable for remote places where the grid is far away and the power transmission is difficult. So in that case, we can go on with a small wind turbine where it supplies the generated or energy or harvested energy is utilized in the residential or the local community or the people. They're also suitable for remote places, as I mentioned. Okay, and small wind generators. This type of turbines uses small wind generators. This provides isolated power systems for a household load, and they are also obviously they'll be connected to the batteries. Okay, and medium wind turbines usually provide uh, power between 20 kilowatts to 300 kilowatts, and whereas the small one, as I told, it was less than 20 kilowatts. So medium will be ranging from 20 to 300 kilowatts. And this, they are usually used to either remote loads that need more electrical power or commercial buildings. Okay, so this usually have a blade diameter of 7 to 20 meter, and the tower is not higher than 40 meters. It doesn't have a very higher tower range, I means the height. They're also never connected to any sort of battery system. They're directly connected to the load through this DCAC, means inverter sort of power electronic converters being connected along with that. So moving on to the last one, the large wind turbines. So they are obviously, from the name itself, they deal with the megawatt power range. These turbines incorporate complex systems, and the wind farms typically consist of obviously, several to hundred, large number of turbines. So the price, of 1 kilowatt installed power in such a large sort of biggest wind turbine in globally, like in Germany, it is done by a German company known as Enercon. So the price of is, from a larger wind turbine is significantly less than the price of 1 kilowatt obtained from a smaller turbine. So currently, you know approximately it will be $500 per kilowatts, and so the price energy will be, of course, cents per kilowatts. So this is the classification or the details regarding the wind turbine. So it's based on the power capacity requirement, or the place, remote place, commercial or the residential, or to the grid. Based on that, we connect it either small, medium, or large. And also based on the axis position, we go on with the horizontal or vertical. Obviously, most of the times we go with horizontal. At rare cases, we go with the vertical. As we have seen, it has its own advantages and disadvantages. Thank you.